All right, welcome to a video for Math 1, Section 1.5, which is on rates, ratios, and conversions, I think is what it was called. All right, so we're going to be using this right here, which is the Frayer Model Vocabulary Sheet. So I'm going to show you where you can find this. This is in the Interactive Notebook General Files. So I'm going to show you on Canvas. So here's the Math 1 Canvas page. And let's see, Math 1 Course Documents is where you want to go. And there's 3 folders here. You want to click on the second one that says General Interactive Notebook Documents. It's going to take you to this page. The one that you need is the one that says Frayer Vocab Blank 4. Click on that. And it opens up the page that I'm going to fill out. Okay? So you're going to want to print this before I get started. And we're going to go over her 4 vocabulary words. We are going to put them in your notebook later. So don't worry about adding this into your notebook yet. If for some reason you can't print this page out, I want you to, you can either get like index cards if you have any and kind of break them up into 4 sections like this, or you could just get a blank piece of paper and draw this. Either way, okay? So our first word is going to be ratio. So we put the word in the middle, in the oval section here. And then we're going to put a definition, some characteristics, examples, and non-examples. Okay, so let's start with the definition. All right, so where it says definition, we're going to write the definition for a ratio. Okay, a ratio compares 2 numbers, specifically by division. Okay, some characteristics of a ratio. First, it always should be something that's reduced. And there's 2 ways to write it. All right, so to write a ratio of A to B, there's 2 ways. You can write A over B as a fraction or A colon B. The order does matter. So if I say a ratio of A to B, then whatever the A is needs to be on top or first. And whatever the B is on in the denominator of the fraction in second. Okay, so some examples. Ratio could be something like the ratio of boys to girls in a class. Okay, so for example, let's say we'll have the ratio of boys to girls in a class. So let's say I have an imaginary class and I count how many boys and how many girls, and I find that there are 15 boys, right? Because it's first, so it goes first, to 10 girls. Now this is not reduced, so we need to reduce that. This could also be written as a fraction, so that might help you reduce. See, we can reduce this by 5. I can divide 15 by 5 to get 3, and I can divide 10 by 5 to get 2. So then you can do the same reduction for this notation, okay? But it's important, it says boys first, so this is the number relating to the boys, and this is the number that is relating to the girls. Okay, but again, we always want the reduced ratio. So what this ratio means is for every 3 boys, there are 2 girls. All right, a non-example of a ratio, maybe we're just looking at one number. Maybe we're just looking at like 12 boys. That's not a ratio, that's just one number. And we have to have division in some way going on. We're comparing 2 numbers. All right, so now we're going to go on to the next word, which is rate. So let me move this around just a little bit. All right, so we're doing rate now. A rate is a type of ratio. So I'm going to put a characteristic that says that. It is a special type of ratio. So its definition and what makes it different from just a regular old ratio, it is a ratio that compares quantities, so numbers, and here's the important part, measured in different units. And you may have heard the word rate before when you're talking about something like speed, like miles per hour. If you're going 20 miles per hour, that's 2 different units. Units are things like miles and hours. Okay? So I'm going to use that as an example. 20 miles per 1 hour. So this is a ratio. You may be used to thinking of it written like this, mph, but this is what it means. It's a ratio of 20 miles in 1 hour. But it doesn't have to be a speed like you're used to. It could be other things. Maybe it's a rate of 5 shirts per $30 or something. Okay, so that's another example. Or maybe it's how fast you type. Maybe 40 words in 1 minute. Okay, so these are all examples of rates because they all have different units. Miles, hours, shirts, dollars, words, minutes. An example of something that would not be a rate, we can do something that doesn't have different units, like 5 inches to 4 inches. Okay, those have the same units, and so that's not really a rate. It's a ratio, but it's not a rate. Okay. Next word. Our next word is stemming off of the idea of rate. We have something called a unit rate. So a unit rate is a special kind of rate. Okay, it's a special type of rate. Okay, so it's like we're getting more and more specific as we go through these definitions. Right? We had ratios, which include everything we've talked about so far. Then we have rates, which are special types of ratios, and now we're looking at special types of rates called a unit rate. So what makes it special? Well, it's defined as a rate with a denominator of 1. That's an O. That should be an O. Of 1 unit, they say. Okay. So for example, actually we kind of wrote some examples in the last one, right? 20 miles per 1 hour, that would be a unit rate. 5 shirts for $30 is not a unit rate because the denominator is not 1. 40 words per 1 minute, that is a unit rate. So let's think of some other unit rates. Maybe we can be talking about, maybe we can talk about money in the sense that it's like $4 per 1 ticket. As long as it has a 1 in the denominator, right? It still is a rate because you have 2 different units, dollars and tickets. Or we could have, we can put 60 minutes for 1 hour. Okay. Some non-examples, the 5 shirts for $30 would be a good example of something that's not a unit rate because it doesn't have a 1 in the denominator, right? That right there, not 1. Okay, last definition, and then we're going to do some examples in your book. So our last definition is conversion factor. Okay, so conversion factor helps us change from one unit to another, such as maybe feet to inches. Like imagine you're cooking and you need to convert a recipe that's using milliliters into something like that you're used to, that you can measure, like cups. Okay, so you need to know how many milliliters are in a cup, for example. All right, so the definition of a conversion factor, it is a ratio. So it is a type of ratio. It's a ratio of 2 equivalent or equal measures. And these would be in different units. Okay, so its characteristics, it's used to convert 1 unit to another. For example, I don't know why I just put that. From feet to inches. Or maybe from inches to feet. You can go either way. So in the example here, I'm actually going to show you how you would do that. Let's say that I'll give you an example of a conversion factor. Let's say 1 yard equals 3 feet. Okay, so you can think of it like an equation. But then we can write it as a ratio, and we would put it like this: 1 yard over 3 feet. Or maybe you can write it as 3 feet over 1 yard. Since 1 yard and 3 feet are equal, these both equal 1. Okay, so the conversion factor always equals 1. Because when you divide something by itself, it equals 1. And since 1 yard and 3 feet are the same thing, it's like they cancel out and give you 1. Okay? We'll do some examples where I show you how you can use it. Non-examples. A non-example would be just something that wouldn't equal 1. So maybe 24 inches to 1 foot, right? This is wrong. This is not equal to 1, right? This is not a conversion factor then, because we know that a foot has 12 inches in it. Okay, now I'm going to show you something in Google. I'm not sure you were aware that you could do this, but if you go to Google, Google will show you conversions for you. Let's say you want to know how many feet are in a mile. In the search box, type in feet in a mile. And this box comes up, and it is actually almost like a calculator that Google provides for you, where it tells you 1 mile equals 5,280 feet. And you can even plug stuff in. Let's say you want to know what 4.5 miles is. It automatically calculates for you how many feet that is by essentially just multiplying that by 5,280. Okay, and anything you want, really. We can do yards in a kilometer. Okay, there you go. Gallons in a liter. Okay, so 1 liter is 0.264172 US gallons. Okay. Another thing that's helpful is one thing that you're going to need to use conversion rates for in real life is if you go and travel to other countries that use different currencies, you're going to have to exchange your money, US dollars, for their currency. Such as in Europe, they use something called the euro. So you can type euro to dollar. Okay, and a little bit more information is going to come up in this case. They'll tell you 1 euro equals 1.13 US dollars. Okay. Or if you want, you can change the US dollar to 1, and then they'll tell you that $1 equals 0.89 euros. Now, this is something that's not consistent because of financial markets and things like that. This can change even day to day. And so you can see right here they provide a chart for you that shows how this amount has changed over time. And that's helpful for if you want to go travel to a different country. If you go at a time where the US dollar is worth more at that particular time than the currency that's there, it'll be a better value for you to travel at that time. Okay, so, and they even let you change the you can change the currency to anything you want. There's lots and lots of different currencies you can choose from, like the Japanese yen, for example. So I can change 1 Japanese yen is equal to a penny. So don't think that 1 yen equals $1, because it doesn't. Okay, so we're going to look at a few examples in your textbook. So if you need to, pause the video, go get your textbook. All right, so I'm looking at page 38 of your textbook. All right, here's number 1 on page 38. It says, Trisha ran 10 kilometers in 2.5 hours. Jason ran 7.5 kilometers in 2 hours. And Olga ran 9.5 kilometers in 2.25 hours. Who had the fastest average speed? So in order to compare their speeds, we need to get them into unit rates. Okay, so for each person, we'll start with Trisha. So Trisha has a rate, and then she has a unit rate. So Trisha's rate is 10 kilometers in 2.5 hours. But we want to put it in a unit rate so that we can compare them all. So to get from this to something that has a denominator of 1, we need to divide 2.5 into 10. So we can pull up a calculator if you need to. Divide 10 by 2.5. Bingo, you get 4. So this is, let me put it down here, 4 kilometers in 1 hour. That's the unit rate that we get here. All right, so then now we're going to do that for Jason and Olga, and then we can compare. So I want you to pause the video, and I want you to do the same thing for Jason and Olga. And then I want you to try and figure out who had the fastest speed. And then once you have your answer, click play again, and then we'll see if you got it right. Okay, so these are the 3 unit rates that I came up with. For Jason, we had 3.75 kilometers per 1 hour. For Olga, it was 4.2 repeating kilometers in 1 hour. And we had that Trisha was 4 kilometers in an hour. So we're looking for the fastest speed. The fastest speed is Olga's. This is the fastest speed. Did you get it right? Okay. Next I want to go ahead and we're going to do some conversions. So we're going to look at 3 at the bottom of the page. So we need to convert, it says convert the given amount to the given unit. So we have 63 yards, and we need to turn that into feet, right? So we know that 1 yard over 3 feet is our conversion factor, or you can write it as 3 feet over 1 yard. So we're going to take, and remember, this is just a 1. Both of these are just 1s because these quantities are the same. So we're going to multiply 63 by a 1. You can multiply 63 by 1 and it won't change its value, right? But the one I'm going to multiply it by is going to be this one. So it's 63 yards times 3 feet over 1 yard. Now the reason I chose this second one here is because I want the units to cancel. Just like if you have like 5 over 1 times 2 over 5 and the 5s cancel, units can cancel too. So I have 63 yards over 1. The yards are going to cancel, so I want them diagonal from each other. And then all I have to do is multiply 63 times 3, which is 189 feet. Okay, let's do number 4. So in this case, we're working with hours and days. And so our conversion factors could be 1 hour to, 24 hours to 1 day, or 1 day to 24 hours. Guess we don't need the R. Okay, so I have 168 hours. Which one do you think we need? We need this one because the H is going to need to cancel. So 1 day to 24 hours. So the H is going to cancel. The hours are going to cancel. And then in this case, we have a division going on here. We have 168 over 24. So we need to divide this time. 168 divided by 24. That gives you 7. And then the unit that's left over, remember, is days. So this is how many hours there are in a week. All right, one more example. We're skipping a page. We're going to page 40, and we're going to look at this one right here, which it says problem for converting rates. It says an athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? So we have this rate of 100 feet in 3.1 seconds. We need to turn that into a different rate, and this time we want miles per hour. So something miles over something hours. And specifically, because we want miles per hour, that means that this has to be 1 hour down here. So it is a unit rate. So we have to turn feet into miles and seconds into hours. So we are going to use a couple of different conversion factors here. So let's start with getting feet into miles. We looked that one up on Google. We saw that 1 mile equals 5,280 feet. So we can use 1 mile over 5,280 feet. And I want the feet in the denominator because right here it's in the numerator. So I'm going to do 1 mile over 5,280 feet. That way the feet will cancel. Now that'll help with the feet, but how do we get to the seconds? With the seconds, we're going to have to get from seconds to hours. Okay, well, you're going to need 2 different conversions. You're going to need one for seconds to minutes and one for minutes to hours. So from seconds to minutes, we know that 1 minute is 60 seconds. Now that one's not going to work because the S is on the bottom. We need it to be on the top. So the 1 minute is going to be on the bottom. The 60 seconds is going to be on the top. That's the one we need. Okay, so I can see that the seconds here are going to cancel. But we're still not in hours. So now we need to go from minutes to hours. So 1 hour is 60 minutes, but again I need the minutes to cancel with the minutes here. So we're going to do it as 60 minutes on top over 1 hour. Okay? So all of these variables that need to go away, or not variables, sorry, units that need to go away are going to cancel. So the feet, we saw cancel. The minutes are going to cancel, the seconds are going to cancel, and the units that you have left are going to be the ones that you want to be left, specifically miles and hours. And then from here, we just have some numbers that we have to deal with. 100 times 60 times 60 divided by 3.1 times 5,280. Okay? So let's do that. So let's multiply all the numbers on the top. So 100 times 60 times 60, big number. And then I'm going to divide by this and then divide by that. So 3.1 equals, divide by 5,280 equals, okay. And we're good. It's not going to be a pretty number. And something's not right. Doesn't that seem a little fast? Let's use our reasoning skills, to recheck my calculations here because something doesn't feel right. We're talking about an athlete running. Okay? Do you really think he can go 219 miles per hour? So I'm going to clear this and I'm going to try again. So let's see, 100. Oh, see there? I got an extra 0. That might make a difference. 100 times 60 times 60 equals, yeah, that has one less 0 than it did before. Okay, then let's hit divide by 3.1 equals divide by 5280. Okay, this is a lot more reasonable. If you're running really, really fast, this is about 22 miles per hour. That's kind of reasonable if you're running really, really fast. Okay. 219 was not reasonable. So we always want to use our reasonable skills, especially when using calculators, because one little extra button we may not realize could get us a very incorrect answer, but we humans need to realize that it's not right. We can't always trust a calculator. Although the calculator will always do what we tell it to do, but sometimes we tell it to do things we didn't mean for it to do, such as put in a 1,000 instead of a 100. Okay, so there's our answer. 21, or we can round it. So round it to the nearest mile, so that's about 22 miles per hour. All right, this lesson is done. I will tell you how to put those vocabulary cards in your notebook next week.